So DataRobot is enterprise-grade AI pipelines for your machine learning and generative AI applications. We've been focused on AI since our founding for over a decade. We have helped organizations with many different use cases. I think some of the most impressive ones are 1/3 of foreign exchange actually runs through DataRobot. We've been used as the AI platform of choice for some government bodies, particularly doing drug trade and trafficking in terms of trying to prevent that. We're also heavily involved in terms of vaccine trials with all of the major manufacturers for vaccines. But most importantly, what DataRobot is really about is embedding AI in the business fabric of your organization. So most organizations have multiple cloud platforms of systems of records, and they have million systems of engagement. So how do you actually build really strong enterprise-grade pipelines for your machine learning and generative AI applications and quickly embed them into your business process without making sure that they're brittle and ensuring that everything is hot swappable so that you can keep up as things change? And that is exactly what DataRobot does. So one of the biggest barriers that we see in terms of actually getting generative AI embedded into your business and organization really has to do with collaboration. You have teams who are trying to create AI machine learning that are all using different languages and tools, who then are throwing it over the fence to AI operators, who then have to repackage it up to try and get it out to the business consumers. And this slows down the process. What we do is we give everybody a united platform from which they can work from. So if they want to code, absolutely code. We have hosted notebooks, code in your own favorite notebook. You want a GUI interface, we can support that. But most importantly, it's about registering all your AI machine learning projects, your generative AI applications, and getting them out to production. And not just production, but make sure that they're continuing to perform safely and securely. All right, so what we're really here to talk about. We are going to spend the next quick 15 minutes on trying to convince you why benchmarking LLMs is an absolute waste of time. I know it's a little bit of a hot take on this one, but we have talked about this. And what we're bringing this as a topic is because of all of the organizations that we have worked with. And we're seeing what works and what fails. So we're helping to bring that insights with you. So we're going to talk to you about the 5 key areas you should be thinking about when you are looking at creating your generative AI applications, how to benchmark, where to benchmark, and then how to do it and actually look for it. So first thing, benchmarks for LLMs, they're not actually going to tell you anything useful. The reality of it is LLM benchmarks give you a very false sense of performance. It's very much like this photo. Can you touch your toes? Well, it looks like they're touching the tips of the toes of their shoes, but are they actually touching their toes? And the reason is there are 3 key problems when it comes to benchmarking LLMs and using them to evaluate if they're going to be the right LLM for your use case. And one of the first one is they cheat. Now, are they intentionally cheating? Sometimes not. But what they've been trained on is a wide set of data. And then it could be in the sample data that they're being introduced to is very similar to data that they've already seen. The other thing is vendors are actually stacking a lot of these LLM benchmarks in their favor. So they may be comparing their large language model to another company's smaller language model. Or it could be in the way that they're testing the prompting strategy. They could be using a very different prompting strategy for one LLM versus another. And the other thing is each vendor actually creates its own benchmark for LLMs. There's no standardization, so you're not really comparing apples to apples.
And I do just want to quickly double click on that one because it's important. You'll often see when a lot of these large language model providers introduce a newer version and they have the associated benchmarks, they're going to typically rank really high. And if you actually double click into the fine print, you'll realize that oftentimes they'll apply a different, more advanced prompting strategy, and they'll compare it to something like a zero-shot strategy for one of the competing vendors or the competing language models. And I liken it a lot to something like shovels, where it's not always the size of the shovel that matters. It's often how you use it. I think everyone here is probably aware that the right or correctly crafted prompting strategy, if you're using something like chain of thought or tree of thought, can actually substantially boost the performance. So not everyone compares these apples to apples in a fair sense.
And then we always hear, but it can answer the math problem really, really well. And that's great. But is that LLM going to be useful for you in terms of the use case that you're actually going after? Do you need it to answer the math problem correctly? If you're using an LLM to create a generative AI application to do something like creative content creation, like emails or next best offer, does it need to be really good at math? And so there's a false sense of what LLM benchmarks can give you in terms of performance that aren't necessarily accurate. And if you really think about it in terms of an LLM, and it comes to the solutions that you're creating, it is really the tiniest piece of your overall process. So using a benchmark on your LLM to evaluate if your actual pipeline and your use case is going to be performant is a false sense of security. It's not going to tell you if an LLM is going to be better or worse at hallucinating, because the reality of it is all LLMs will hallucinate. So it's how you're building everything else around it and how you're building that pipeline and evaluating the metrics and contextualizing your entire experience that's going to be the biggest difference for you. So how to think about benchmarking. I'm going to pass it to Justin now.
Yes. So I'm going to go over a brief overview of how we like to propose you start your benchmarking. And when Lisa said that we don't truly believe in the value of ranking or benchmarking large language models, what we actually mean is that we don't find a whole lot of value in a lot of these industry standard benchmarks. And the biggest reason is that they don't reflect the data that these production grade systems are actually going to see when you deploy them to the real world. And I think a really good analogy is standard or traditional supervised machine learning. Every time you tackle a net new problem, you're always going to have a holdout data set, some unseen data that you set aside you can use to then evaluate how well your model will generalize to the future once it's put into production. We need to create the equivalent of that with generative AI that is highly specific or relevant to your use case and domain to actually understand how well it performs. And that's key. The second big key is that these language models don't run in isolation. You're not only testing the performance of the language model on its own, which is how these industry standard benchmarks are actually stack ranked. When you deploy a model, you're more than likely going to use an approach like RAG or some type of agentic workflow, which means you're adding a whole bunch of additional pieces that Lisa just outlined. There's the chunking strategy. There is the embedding model. There's the actual documents you inject into your vector database or vector store in the first part. And you've got to evaluate the entire system as a whole to understand the holistic importance. So if we double click into what some of these look like, the first step is actually to create that baseline data set that is specific to the application you're building. And if you miss that, then you might actually incorrectly pick a model that may rank highly on the leaderboard that performs relatively worse in your domain. So a big piece of this is actually creating a synthetic data set. There's a lot of really popular approaches where you can create these question-answer pairs from your underlying knowledge base or vector database by leveraging a language model to create that groundedness or ground truth data you can then use to create standard data science metrics. You can objectively rank the performance of your system rather than just the language model. And in terms of how the system breaks down, we typically talk about these 5 categories. There's the choice of the language model, which I'll argue is one of the, while important, less important pieces. There's the chunking strategy that I mentioned, how you split your documents up. Then there's how you vectorize them. How do you convert that free text or the multimodal images, video, audio, et cetera, into the arrays? Which vector database do you use? Which retrieval strategy do you use to pull that back at question time? And then finally, what additional guards do you wrap around the model? How do you test for a lot of these failure modes in production? And what this ends up looking like is this chart, I guess above me at this point, where we like to think the language model is important and the prompting strategy is important, but more often than not, you can get a less performant language model to output better scores and higher quality responses if you focus more on the second and third bubbles here. The retrieval strategy and the actual documents that you inject or index into your vector database. And then most importantly and most overlooked too, the actual data quality. I know no one likes this, it isn't sexy, but the documents and the fact that you don't have gaps in your vector database and you're accurately picking the right document or chunk at the right time is the single most important thing. If you don't pass your language model the correct answer, it can't possibly synthesize a good response. Now, if we flip the page to actually understanding the choice of language model, just to better understand how these benchmarks might not tell the whole story, you can actually categorize them into these 3 different pillars here. There's the size, obviously. You've got some language models, especially the newer ones, that have billions, if not a trillion parameters. There's also a lot of hyper-optimized small language models. One thing that we found that might be counterintuitive, if you're building an agentic workflow, you want to invoke some type of tooling, some of these smaller models that are fine-tuned for that exact decision-making actually perform better because they aren't going to be bogged down with all that general context. You can actually tune them to invoke the correct tool at the right time based on the user's question, and that's going to allow you to create a really simple, straightforward, objective test set that you can then easily assess or evaluate before you push that to production. The second dimension is going to be open source versus API-based. This is something that you want to run locally versus something that you're willing to share your data through a third party, like an OpenAI, for example. And then the last one is actually fine-tuning some of these models for a particular domain. And the trade-off here, I think Bloomberg GPT is a great example, is that the more data you feed it to update the weights or add new nodes to the network and then train those weights, the better it gets at that particular problem, but the worse it gets at everything else. So when you take this approach, you actually need to constrain the model by adding guards to make sure it only answers questions that are in scope. And then just to actually walk through a few of these strategies and underscore some of their importance, we talked a bit about chunking and embedding models. This is really important because when you look at a generic data set, these embedding models almost certainly have seen all those tokens. They've been trained on them. But in the real world, when you're actually trying to build one of these RAG pipelines, you actually might encounter a rare token that the embedding model wasn't actually trained against. And one example that I encountered recently was with an airline. You can imagine you might have an initiative like Delta Sky Miles. That term means something particular. And when you actually go to embed that, if the token wasn't included in the training data set, you'll have a poor similarity score. So you won't be able to pull that up, and it won't understand the semantic relevance of that exact term. And then in terms of vector databases, 2 quick points I want to make here. One is that the actual documents you inject into the vector database and the quality of those documents, preventing duplicates, incorrect or outdated information, is far, far, far more important. You can imagine that searching on any of your internal repositories, finding outdated articles, articles that haven't been updated, the language model is not going to know any better. And also making sure that you focus or narrow the scope. If you have a bunch of different problems, you might want to actually create multiple vector databases to help out these language models. Again, the typical benchmarks won't address for these different concerns. And then finally here, the different guard models. How do you actually run an appropriate assessment? Well, you want to create both an objective measure, a subjective measure, and custom measures. And there's a whole bunch of research and literature around this. On the objective side of the house, you're going to want things like RAG is a great example, and then subjective could be human feedback. And then finally, just to recap here, 3 quick points. One is that these benchmarks can often give everyone a false sense of performance because they've been tested on data sets that aren't really reflective or indicative of the real world. 2, you should always test, compare, and contrast multiple language models, but also multiple strategies. So think of it as an entire system rather than just a model. And the third one there is focusing on the full RAG or agentic pipeline so you can evaluate the full input to output, not just one piece of that whole puzzle.